So whenever you want to measure the activity of your assay, you want to look at the units, which is micromoles per minute. So the equation for the activity is given right here. Here. So to look at each component, you have the change in absorbance over time of the linear portion of your graph. So you want to avoid the region on your graph where it starts to curve. And that's measured in per minute. And then you divide that by your extinction coefficient for NADH, which is going to be 6,220. And then you multiply that by the qubit path length. And for all of us, that should be 1 centimeter. And then you multiply this by some unit changes. So here you have 10 to 6 micromolar per molar, and you multiply that by the volume of your reaction. And for our purposes, this was 1 milliliter, so that's 0.001 liter. So that gives you the activity of your assay. So once you have that and you want to find the relative activity, you take your activity and you divide that by the amount of protein in your cuvette. So let's say you use 5 microliters. That's equal to 0.005 milliliters. So you'll divide your activity but over 0.005 milliliters. And if you did a dilution factor beforehand, say you took 10 microliters and you diluted it into 100 microliters, that would be a dilution factor of 10. So you'll multiply your relative activity in the end by 10 to account for that initial dilution. Now at the end, when you want to find the specific activity of your sample, you take your relative activity and you divide it by your protein concentration, generally in mg per mil, and you'll find that from your Bradford. And that gives you the specific units or specific activity of your sample, which is generally like a measurement of purity of your sample.